Hey, welcome back to Well, That's Interesting. Oh, thank you so much, it's something I always wanted edition. Today is episode 259. First non-human creature to navigate using the Milky Way is the Dung beetle. And the earliest supernovas may have created water, which is super important. My friends, it's that time of year when the jingle-jangle of the Christmas season is pretty much inescapable, and the pressure to give and receive things we don't really need is on. But today, I'm going to give you not one, but two presents in the form of topics that won't take up any room in your home, but a sizable portion of your heart. You are going to love this. In the first half of the show, your first gift, poop and tiny hats. Stick with me here. Let's start with the poop part first, and by that I mean provide a little background information on a little creature whose lifestyle is not for everybody. Of course, I'm talking about Scarabaeus satirus, an African species of dung beetle that, if you've ever watched a nature documentary on the South African savanna or parts of East Africa, including Kenya and Tanzania, then you've probably seen B-roll of these stout, heavy-bodied insects rolling balls of elephant poop off into the distance using their back legs. And you may have quietly and politely asked yourself, what the fuck? And why? Those are great questions to ask. Turns out our hot-for-piles beetle does this for a few important reasons. One, it's heading towards an underground chamber where it will feed on the dung without being disturbed, and that is totally understandable. Two, during breeding seasons, the poop balls belonging to males turn into sports cars that females just can't resist. They actually hitch a ride on these balls-turned vehicles. The male tumbles back with both of them to his underground chamber, whereupon the female will lay an egg inside that ball-turned vehicle, transforming it now into a ball-turned vehicle-turned incubator. The larva feeds on this single source as it undergoes a complete metamorphosis through the pupa stage to emerge as an adult. So, for S. satirus, shit is serious business. Now, rolling your food source or your baby's food source away from a load to your sweet, sweet chamber during the day is generally a straightforward task. As reported by the aptly named Christine Delamore of National Geographic, scientists already knew that dung beetles can move in straight lines away from dung piles by detecting a symmetrical pattern of polarized light that appears around the sun. We can't see this pattern, but insects can thanks to special photoreceptors in their eyes. End quote. But, get this, S. satirus is mostly nocturnal. They work day and night, even under moonless skies. Under that environment, how in the holy hell does an insect no bigger than 1.2 inches craft a round ball of poop and know which direction to head, all while going in a straight line? I mean, personally, I'd have to take out my phone and GPS that crap. No pun intended. Study co-authors Eric Warrant, a biologist at the University of London, Sweden, Marie Dacke, neuroethologist at the University of Lund, and their colleagues were determined to find out how. And thank God they did, because I can show you the little hats they created to block the beetle's vision. We will head to South Africa and roll into their study, which tested the navigational abilities of this creature inside a planetarium under different night settings. As it turns out, they're using a galaxy to figure their shit out. Hey, look, I'm sorry. There's going to be one too many jokes like this today. Then after the break, if you had any water today, straight up or inside something as an ingredient, then I have some news for you. And this will be your second gift. Thanks to a recent study, it's likely that some of the water we enjoy has been cycling over and over, starting as early as 100 to 200 million years after the Big Bang. And that's because, it seems, the first oxygen molecules created were found in the heart of the first stars. And these molecules found their way out through the first supernovas. We will drink in the study, led by astrophysicist Dr. Daniel Whalen from the University of Portsmouth's Institute of Cosmology and Gravitation. We will meander through his team's simulations. We will be amazed at the possibility that stars and water existed before galaxies and what the early universe was like. I've got chills, y'all. In the meantime, hi, I'm Jill Chacha, and if this is your first time listening, welcome to the flock, my drenched business goose. begin, I dare ask, when was the last time you enjoyed your favorite substance while under the dome of a planetarium? Now, I don't know where your mind went, but for the African dung beetle, S. satiris, it's a nice smooth ball of shit. But I'm getting way ahead of myself. And, as it turns out, so was neuroethologist Marie Dacke of Lund University in Sweden. After a series of experiments with our chonky beetle friends in 2005, the Dax and her fellow researchers published a paper that not only confirmed what earlier work had shown, that beetles can orient themselves using the polarization in sunlight and moonlight, aka they follow light waves moving in a single direction, but that beetles don't use landmarks, like rocks, trees, or even starlight. In that work, she and her colleagues reported that beetles actually lost their sense of direction if they could only see stars and not the moon. As the years went on, Hot for Dung beetles Dacke continued surveying these adorable literal shitheads, but something didn't sit quite right. Even on those moonless nights, many beetles still managed to orientate themselves along what looked to be a clear path. So, in proper neuroethologist fashion, between February and March 2008 and 2009, another experiment was called for, just to clear things up. The Dax hitched up her pants, scattered some scat under a full, quarter, crescent, and new moon, and waited for the beetles to fly in. If you drop whatever scat you're holding right now and pick up your phone to head on over to today's post on the old socials, you'll see a photo of S. satiris in all of her armored, shiny glory, and then 4 circular diagrams, each representing a tiny arena under a phase of the moon. Inside each diagram are a series of lines extending from the center to the radius. These indicate the paths each beetle took away from the poop pile placed in the middle of the arena. I'll give you a second to absorb what you see, specifically focusing on how straight each path is during every moon phase. Yeah, is that not wild? Now, if you're too busy scattering some scat yourself and you just can't pick up your phone to take a peek, don't you worry. I can describe what this bombshell of a study discovered. Under a full, quarter, and crescent moon, each little beetle was able to roll their turdy package in a beeline to the outer area of the arena. Easy peasy, no problemo. In that last diagram, representing how beetles performed under a new moon, or lack thereof in the sky, well, to be honest, the paths are more of a curve, meaning it took them longer to orient themselves out of the arena, but looking closely, there are no turns, no veering way off to one side or going diagonal, no one backtracks. The paths may be curved, but it certainly looks like a determined direction. Thanks to this study, it seems as though our chonks are using more than just the moon to get around. And this is when the Dax had her eureka moment, seeing the tiny errors in her ways. According to Susan Milius of ScienceNews.org, during the previous 2005 study, the team tested the beetles in October in South Africa, when the Milky Way was so low in the sky that the animals couldn't get a good view of the 5,000 to 6,000 stars that could be seen with the naked eye. In sum, it just wasn't fair to say beetles don't use starlight at all when you yank up to 6,000 stars away from them. This 2008-2009 study seemed to confirm something else is at play here, and it just might be very specific stars. It was time to correct this wrong and figure out once and for all what the crap the dung beetles were using in addition to moonbeams. And Dacke and the gang did so in the most precious way possible. So, join me, will you, for part 1 of Experiment 3 within a game reserve nicknamed Stonehenge, a mere 70 kilometers or 45 miles northwest of Vryburg, South Africa. And for my fellow geographically challenged Americans who may be like, wait, isn't Stonehenge in southern England? Yes, you're right, well done, but this is a different Stonehenge, so please imagine Africa. Thank you. Point to the very southern tip, and there you'll find the aptly named South Africa. Move your finger from the center up just a smidge, and here we are, within the reserve in February and March 2009. We're here with the team and hot for dung beetles Dacke, who also happens to be hot for circular arenas when it comes to experiments. And for good reason. According to their revealingly titled paper, Dung Beetles Use the Milky Way for Orientation, quote, On a starlit night, beetles were released with their dung balls from the center of a circular arena of flattened and leveled sand, enclosed within a 1 meter or 3 foot high featureless circular wall. In the previous experiments, the beetles could possibly have used overhead landmarks, such as treetops and the camera gantry, as an orientation cue. To remove all such visual cues, including the observer, we designed a second arena with a circular black cloth wall about 1 meter in height that obscured all terrestrial landmarks. From within this arena, the beetles could only use visual cues from the night sky to orientate." End quote. So yes, my speedy business goose, the hounds were released into a 120 centimeter or 3 foot wide shitfest, and the only way out was to use the heavens above for guidance. Each beetle would be tracked and recorded for time as they made their way to the far edge, using 1, the moon, 2, the clear starry night, 3, the sky under a cloudy overcast, and 4, this is my gift to you. The beetles were also fitted with tiny hats to obscure their vision and prevent them from looking up. And I swear if you're driving, don't even pull over. There's no time. You need to see this right now. Just take out your phone and tap on today's post. There you will find a small beetle wearing what looks like a tiny silver baseball hat meets Handmaid's Tale situation. It's adorable somehow, and you are very welcome. As a control, the team also donned beetles with transparent plastic versions of the same shape, just to make sure it wasn't the fit or the cap itself that impaired the bugs. So just imagine that's happening as well. My God, I can't take it. Okay, so after all the beetles were released under these circumstances, what were the results of part 1 of experiment 3? Drumroll, please. Thank you in the back. Well, if you swipe past that fashion show, you will see 2 circular diagrams that say it all. The one on the left indicates paths taken under a clear night, and the one to the right shows the paths of beetles wearing those sky-blocking hats. Y'all, that diagram on the right is an absolute clusterfuck. For the first time, we see U-turns, bugs walking in circles. I have no idea what the one in red was up to, but it looks like somehow they successfully drew a beetle self-portrait. It's impressive. Anyway, to put these lines into perspective, the study provides a handy-dandy graph chart of the time it took these beetles on average to leave the arena versus what the hell was going on above them. With the moon in view, it only took an average of 20 seconds to Uber their ball out of there. 40 seconds when exposed to stars, just under 2 minutes when the sky was overcast, and just over 2 minutes when wearing tiny hats that prevented them from seeing the sky at all. Well, as the paper so accurately put it, quote, "A view of the clear starry sky is important for straight line orientation, and this is further supported by observations of beetles rolling under a completely overcast or blocked sky in the same arena." End quote. Now, I can see your face from here. That look says, Jill. Oh, Jill, I love my present. Really, it's great. But phase 1 only shows that stars are important to beetles. But which stars are we talking here? If you were thinking that, you are absolutely right. That's where phase 2 comes in. So please, grab your favorite substance and join me, will you, now at the Wits Planetarium in Johannesburg, just a bit northeast of Stonehenge. According to the WITS website, here you'll find, quote, "a digital dome featuring high-resolution projectors, surround sound technology, auditorium seating to create a state-of-the-art immersive environment for pioneering storytelling with breathtaking displays and interactive educational resources, creating engaging experiences to captivate audiences of all ages and diverse interests." End quote. I almost passed out, my God. In sum, it is the perfect place for dung beetles to have the goddamn time of their lives rolling their favorite substance around under a digital experience for the ages. Indeed, for phase 2, the team moved the arena into the planetarium and under the dome, exposing the beetles to 5 out-of-this-world trips. 1, the complete starry sky with more than 4,000 stars and the Milky Way. 2, the Milky Way only. 3, 4,000 dim stars, with the 18 brightest excluded. 4, 18 brightest stars only. And 5, total darkness. So, what the fuck happened? Drum roll, please. Thank you in the back of the auditorium. Let's work backwards, shall we? To no one's surprise, with only the 18 brightest stars available as an orientation cue or fumbling around in total darkness, the Beatles took significantly longer to reach the edge of the arena, 80 seconds and 2 minutes, respectively. With the help of 4,000 dim stars, though, things started to get better. On average, they rolled out of there in about 65 seconds. And this leaves us with the full projection of the starry sky, including the Milky Way, or only the Milky Way. And guess what? Exposed to each, the Beatles booked it in about 40 seconds and then 50 seconds on average. That's only about a 10-second difference, which means, you guessed it, that on a moonless night, S. Satiris orientates using the bright band of light produced by the Milky Way. If that sounds impressive, it truly fucking is, for a couple of reasons. First, as reported by Rachel Funnell of IFL Science, the team also discovered that, if a little lost, the Beatles will climb on top of their dung balls and perform a little orientation dance of sorts. This makes it easier for them to locate some light sources that can put them back on course. So they may have a hierarchy of preference when it comes to choosing the stars and the moon and the galaxy. And 2, this is the big one. Quote, "This is the first time we have shown that insects can use stars to guide them for orientation, and it is also the very first proof that animals can use the Milky Way for their orientation." End quote, the DAC said in an interview with ScienceNews.org. Yeah, the dung beetle, of all creatures, is the only other animal, other than us humans so far, proven to navigate using the 100,000 light-year-long streak of the galaxy. That is a hell of a fun fact to bust out at an awkward moment. But if you're like me, you'll probably need more than one because there will be more than one moment. So feel free to use these as well. Indigo buntings, which sounds like a band from the 90s, is actually a species of bird that also uses the stars to navigate. They migrate at night, flying as far as 2,000 miles. But before they take off, they face in the direction they have to go. And to do that, they look for the North Star Polaris and nearby constellations like the Big Dipper and Cassiopeia. And, believe it or not, our old friends, the chubmarines, the harbor seal, also use the night sky to their advantage. In an ingenious and familiar study by the marine biologists Guido Denhart and his colleague Bjorn Mach, Bjorn, there's only one, the team put chubs into a pool at a Cologne zoo, which was transformed into a bespoke aqua planetarium with 6,000 stars. They discovered seals recognize star patterns and can use them to determine direction in an otherwise ocean void of landmarks. So, if whoever you're talking to isn't impressed by any of this, find a star and walk away immediately. They're jerks. After the break, we're moving beyond the Milky Way and traveling back so far in time that time itself has only begun. The possible origin of water is next. What a fucking gift. Stay tuned.
When the holidays start to feel a bit repetitive, reach for a Sprite Winter Spiced Cranberry and put your twist on tradition. A bold cranberry and winter spice flavor fusion, Sprite Winter Spiced Cranberry is a refreshing way to shake things up this sipping season. And only for a limited time. Sprite. Obey your thirst.
This episode is brought to you by Indeed. You're ready to move your business forward, but first, you need to find the right team. Start your search with Indeed-sponsored jobs. It can help you reach qualified candidates fast, ensuring your listing is the first one they see. According to Indeed data, sponsored jobs are 90% more likely to report a hire than non-sponsored jobs. See the results for yourself. Get a $75 sponsored job credit at Indeed.com/podcast. Terms and conditions apply.
And we're back. We are so back. And my friends, I would like you to take a moment and think about what your favorite soup is. Come on, go ahead. I know I ask you to imagine a lot of wacky stuff on this show, so I get it if this request is somehow the wackiest in its normalcy. But please, go ahead. Personally, I like to fuck with a potato leek or a red pepper corn chowder, but maybe you're into lentil soup, a miso, or French onion. They are all wildly different, but the one thing they have in common is, boy howdy, they are hot. And you need to take a minute before they're enjoyed. This is a pretty good analogy for the very, very early universe. According to science.nasa.gov, which may or may not be active by the time you hear this, quote, after the Big Bang, the universe was a lot like a hot soup of particles, i.e. protons, neutrons, and electrons. When the universe started cooling, the protons and neutrons began combining into ionized atoms of hydrogen and eventually some helium. These ionized atoms of hydrogen and helium attracted electrons, turning them into neutral atoms, which allowed light to travel freely for the first time, since this light was no longer scattering off free electrons. The universe was no longer opaque. However, it would still be some time, perhaps up to a few 100 million years post the Big Bang, before the first sources of light would start to form, ending the cosmic dark ages. Exactly what the universe's first light, i.e. stars that fuse the existing hydrogen atoms into more helium, what that looked like, and exactly when these first stars formed, is not known. End quote. My friends, once horrifically large quantities of particles began to cool, they solidified into horrifically large clouds of mostly hydrogen, under which their collective mass condensed into what we call population 3 stars. These were the oldest stars, the first to appear in the universe, shining the earliest beams of light into a young universe that had finally cleared its hot mess of a room from particle clutter. We have yet to find and directly observe Pop 3 stars because their light has, at this point, been traveling some 13 billion years. And as such, stretched into such long red wavelengths, our current technology is still having no luck finding them. But we do know they existed. And we know this because population 2 stars exist. Pop 3 stars were something of a wild child, born right out of the gate, perhaps a mere 100 to 200 million years after the Big Bang, so they mainlined all the pure hydrogen they wanted. They were fucking massive and burned with an equally massive fury, fusing that hydrogen into the first helium molecules and those into the first heavy metals. Eventually, these Pop 3 stars got too big for their britches and did what all colossal stars do at the end of their life when there's no more material to fuse. They collapse under their own mass and explode into supernova. Relatable. Population 2 stars are the quintessential middle child. They inherited the first hand-me-downs, being these metals, and we know that they're out there. But everyone is paying attention to population 1 stars, the youngest, like our sun. When Pop 2 stars nova, they pass on these inherited materials and their own from their own fusion to Pop 1 stars, who will be recycling these materials and, pumping out their own elements after billions of years. Now, although what I've just said is about 2 pages of notes, it took about 14 billion years to occur. That is so fucking crazy to think about. But so are essential questions, like, in all of this creation, when did water squirt out? Because, as we know, that's kind of why we're all here. Well, first, before I provide a possible answer from a new study published this past January, let's flip out a little over just how common water actually is. According to jpl.nasa.gov, which again I hope is live by the time you hear this, quote, the chemical elements in water, hydrogen and oxygen, are some of the most abundant elements in the universe. Astronomers see the signature of water in giant molecular clouds between the stars, in disks of material that represent newborn planetary systems, and in the atmospheres of giant planets orbiting other stars. Oh, by the way, put a pin in giant molecular clouds for me, will you? Okay, thank you. Continuing, quote, there are several worlds thought to possess liquid water beneath their surfaces, and many more that have water in the form of ice or vapor. Water is found in primitive bodies like comets and asteroids and dwarf planets like Ceres. The atmospheres and interiors of the 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, are thought to contain enormous quantities of the wet stuff, and their moons and rings have substantial water ice. Perhaps the most surprising water worlds are the 5 icy moons of Jupiter and Saturn that show strong evidence of oceans beneath their surfaces: Ganymede, Europa, and Callisto at Jupiter, and Enceladus and Titan at Saturn. Scientists using NASA's Hubble Space Telescope recently provided powerful evidence that Ganymede has a saltwater subsurface ocean, like sandwiched between 2 layers of ice. Europa and Enceladus are thought to have an ocean of liquid water beneath their surface in contact with mineral-rich rock, and they may have the 3 ingredients needed for life as we know it: liquid water, essential chemical elements for biological processes, and the sources of energy that could be used by living things. End quote. It is truly infuriating how abundant H2O is, and we still haven't found complex, intelligent life yet, even here. Anyway, until now, scientists thought all this here water built up over time, as hydrogen, still the most abundant element out there, smacked into the ever-accumulating element of oxygen, which, get this, forms as a product from all that fusion and is released when stars go supernova. Well, thanks to researchers from the University of Portsmouth, including the enjoyable-to-say Dr. Daniel Whalen, Dr. Daniel Whalen, it's plausible to think that water showed up on the scene in abundance as far back as when population 3 stars went nova. It's time to unpin that pin from before, the one about giant molecular clouds. My equally giant business goose, the researchers simulated and examined 2 types of supernova. The ones from core collapse supernova produced by stars on the smaller side, about 13 times our sun, and those from POP3 stars, which are at least 200 times the mass of our sun. These puppies would have ejected tens of solar masses of material into space, but both form dense clumps of gas enriched with water too, thanks to producing oxygen. The question is, who produces more water, and by how much? Okay, I can see your face from here, and it says, duh, the bigger ones, and yeah, you're right, but we need to talk about it. So, after all the clickety-clack calculations were made, what did Daniel Whalen and the gang find? Drumroll, please. Thank you in the back. Quote, based on simulations, POP3 stars would have greatly enriched the environment with water. The molecular clouds formed from the remnants of these stars had 10 to 30 times the water fraction of diffuse molecular clouds seen in the Milky Way today. Based on this, the team argues that by 100-200 million years after the Big Bang, there was enough water and other elements in molecular clouds for life to form. End quote. From Brian Koberlein of Universe Today. Oh my God. That is a lot. 10 to 30 times more than the Milky Way right the fuck now. And water may have already been in the works before galaxies even formed. That is amazing, and it was just waiting there to fill our fucking glasses. So maybe we shouldn't be wasting it on cooling data centers. Anyway, just a thought. One setback to this study is that we've never directly observed POP3 stars, so the simulations were based on theoretical models. And 2, according to Harry Baker of Live Science, if there was abundant water in the early universe, it would also suggest that the cosmos should have accumulated much more water than we are currently seeing in our surroundings. One explanation for the absence is that the universe underwent a drying out period, which is also relatable. Other astrophysical processes may have broken up many of these molecules, for example, but even if that didn't happen, water still may have originated as far back as 100 million years after the Big Bang. So please, don't waste it. And thank you for listening, rating, subscribing, and or following on your favorite podcast platform of choice. Tell your friends about those goddamn hats. Just tell them. even if they don't want to hear it, just take them by the shoulders and shake them. And then just tell them about how old water is. And it's just too old. It's just too old. Dear God, and an explosive thanks to the folks over at Airwave Media, the podcast network to which WTI belongs. If you love this show, and you do, you love the other podcasts in this family. And please, stay interesting.